Stuck in the DSA problems and tired of memorizing solutions? Don't worry. In this video, we will break down one of the most commonly asked lead code questions. Remove duplicates from sorted array. We will start with a basic naive solution, understand why it does not scale, and then move on to the optimal solution using the two-pointer technique. By the end of this video, we will be confident enough to tackle similar problems in our next coding interview. Let's get started.
Over the lead code, this is the 26th problem with name remove duplicates from sorted array and is described as given an integer array nums sorted in non-decreasing order. Remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of the nums are not important as well as the size of nums. And finally, we have to return the k. Now what does this mean? According to this, we are given a sorted array of integers. Our task is to remove duplicates in place, that is, without using any extra space. And after removing the duplicates, we are asked to return the length of the array that contains only unique elements. Now here two examples are given. In first example, we have given a nums array with elements 1, 1 and 2. Now if we remove the duplicates, this 1 will be removed from this array and we will have only this 1 and this 2. So the length of the array will be 2 and we have to return that only. Here the output will be 2. Similarly, in second example, we have nums array with elements 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. Now if we remove all its duplicates, we will have only 5 unique values in this array. These values will be 0, 1, 2, 3, 4. Now moving towards its solution of this problem. Talking about the basic approach, what is the first thing that clicks in your mind after reading this problem? Is this the set? Yes, we can solve this problem using set. Let's try to solve this using set. Suppose we have a nums array with elements. Suppose we have a nums array of type integer with the elements 1, 1, 2, 3 and 3. And we initialize a set, suppose with name s. Now if we put each element of this nums array into this set, then it will only have the unique elements. Suppose we take this first element from the nums array and put it into the set, then here we will have 1. Moving towards next element, we will get 1, and when we try to put this 1 into the set, our set already have 1, so it will not add this 1. We will reach to the next element. Here we got 2. Now 2 is not in our set, so this code will add this 2 into the set. Now we will reach to 3. 3 is also not there in the set. 3 will be added into the set. Now again we will reach to the next element, which is also 3, and 3 is already present in the set. So we will not have to add this extra 3 into the set. And finally, we will have only the unique values into the set. Now this is the code for this basic approach. It has the time complexity of big O of n and the space complexity of big O of n. But in the description of this problem, we were asked to solve this problem in space. means we have to anyhow adjust to this space complexity to big O of 1. So let's move towards the optimal approach. Now in this optimal solution, we will use the two pointer approach to optimize the space complexity. Suppose we have an input array nums with elements 1, 1, 2, 3 and 3. Now we will initialize two different pointers, one at the 0th index, suppose this is pointer I, and the next pointer at the first index, suppose this is the jth pointer. Now we will check if the values at these pointers are equal. We can see the values at these pointers are equal. Then we will simply advance this jth pointer. Now this jth pointer will move to the next value. It will be removed from here and will be advanced to this value. Now j will come here. Now we will again compare the values at these two pointers. The value at pointer I is 1 and the value at pointer j is 2. Both are different. So at this time we will advance this I pointer. Now I will move to this value. I will come here and now we will update the value at I with the value at pointer j. The value at pointer j is 2. Now we will update the value at pointer I, which is 1, with the value at pointer j. So this 2 will come here and this pointer j will be moved to the next value. Now similarly, again we will check the value at I is 2 and the value at j is 3. So both are different. Now we will advance this I pointer. I will move to here now and will update the value at I with this value at pointer j. The value at pointer j is 3. We will update the value at pointer I, which is 2 here, with this 3. Now advance this j pointer. Again check the value at I is 3 and the value at pointer j is also 3. So we will not do anything. We will just advance this j pointer. Now we can see that the array has finished. So we will not get to the next value and this iteration will stop here only. We can see there are only 3 values and the I is at the second index. So we will return I plus 1 so that we can get all the values. So finally we will return I plus 1 to get our correct answer. This is the working of this two pointer approach. It will allow us to have a time complexity of big O of n and a space complexity of big O of 1. We can see that the space complexity has been optimized here. So we will use this approach to solve our problem. So to wrap up, the naive approach works but uses extra space. The two pointer method gives us an optimal big O of n time and big O of 1 space solution. This is a perfect example of why understanding core concepts like two pointers and in-place operation is valuable. If you learned something new today, make sure to like, comment and subscribe to the channel. Drop your next questions below and tell me which LeetCode problem you would like me to explain next. Thanks for watching.